Welcome to this channel. In this tutorial, we will design a level sensitive latch using a clock signal. Before going into this tutorial, I request you to like, share and subscribe to my channel below. Click on Components and select the PMOS with explicit substrate connection and place this on the schematic window. Now we have to mirror this PMOS, so use Ctrl E to mirror the PMOS and place this on the schematic window. Again, click on Component and select the NMOS with explicit substrate. Use Ctrl E to mirror the NMOS. Now again click on Components and select PMOS with explicit substrate connection and place this on the schematic window. Click Escape and now again click on Components and select NMOS with explicit substrate connection and place this on the schematic window. Click Escape. Now click on Components and select the PMOS with explicit substrate connection and place this on the schematic window. Click Escape and again click on Component and select NMOS and place this particular NMOS on the schematic window. Next, click on Wire and connect the gate of PMOS to the gate of NMOS and the gate of second PMOS to the gate of second NMOS. Connect the drain of PMOS to the drain of NMOS. Next, we have to place the voltage source in our schematic. So, click on Component and select the voltage source. Place three different voltage source in the schematic window, which is V1, V2 and V3. Now right click on the voltage source V1 and define this as VD. Right click on the voltage source V2 and define this as VDD, and right click on V3 and define this as V clock and click OK. Now right click on the voltage source and define this DC value. Click on Advanced and select the pulse. Define V initial as 0, define V on as 1, T delay as 500 pico, T rise as 10 picosecond, T fall as 10 picosecond and T on as 700 picosecond and T period as 1.9 nanosecond. Now click on this move button and move this particular syntax. Now click on ground and place this particular ground on the schematic window. We have to place 3 ground for the voltage source. Click on wire, connect the negative terminal of all the voltage source to the ground and the positive terminal of all the voltage source must be connected with the wire. Next, click on label net and define the label net as D and place this on the positive terminal of VD source, and click on label net, define this as VDD and place this on the positive terminal of source VDD. Now click on label net and define this label net as clock and place this particular label net clock on the positive terminal of the voltage source V clock. Now, in this design, we also require an NMOS in which the clock signal is applied. So, click on component and select the NMOS with explicit substrate connection. So, to rotate this particular NMOS, use the function Ctrl plus R and place this particular NMOS on the schematic window. Click Escape. Now click on wire and draw the wire on the source of PMOS and name this particular wire as VDD and place this particular label net VDD on all the substrate of the PMOS. Now again click on wire and draw the wire on the source of both the PMOS transistor and define a label net as VDD for this particular wire. Now click on ground and place the ground connection on all the substrate of NMOS transistor which is present in the schematic window, and now click escape. Next click on wire and connect the PMOS to the NMOS and the PMOS drain to the drain of NMOS. Connect the output of CMOS 1 to the input of CMOS 2 and the input of CMOS 1 to the output of CMOS 2. Next, click on ground and place this particular ground connection on the schematic window. Now click on wire and connect the source of NMOS to ground. Now right click on the voltage source VDD and define the DC value as 1 volt. Right click on V clock and select on advanced, select pulse and define the V initial as 0, V on as 1 volt, T delay as 0 seconds, T rise as 10 picoseconds and T fall as 10 picoseconds, T on as 1 nanosecond and T period as 2 nanosecond. Now we have to place this clock on the NMOS. So place this particular label net clock on the NMOS, which is the transistor number 7, and similarly we have to place the input on the NMOS. So place this particular label net T on the NMOS as shown in this tutorial. Now we have to define the models for the transistor. So we are using the PSIM4 model for this particular example. So right click on the NMOS and define the model name as N_50N. Define the length as 500 nano and width as 500 nano and click OK. Similarly, right click on the PMOS and define the model name as P_500 nano. Define the length as 500 nano and width as 500 nano. Similarly, right click on the PMOS transistor, define the model name as 500 P_50 nano and define the length as 50 nano and width as 500 nano. Similarly, define the model name as N_50 nano, define the length as 50 nano and define the width as 500 nano and click OK. We have to define the model for each and every transistor as shown in this tutorial. Once all the models are defined for each transistor, we have to include this particular model file in our schematic. So click on Spice derivative and include this psim4 model in the schematic window and place this particular syntax on the schematic. Now click on labelnet and we will define the labelnet for our inputs and outputs. So define this particular labelnet as Q bar and place this on the schematic window. Again click on labelnet and define the labelnet as Q and place this on the schematic window. Now click on edit and click on spice analysis. Define the stop time as 10 nano and place this on the schematic window. Save this particular schematic in the folder where the psim4 model is present. Now right click on the transistor number 7, define the model name as 50 nano and define the length as 50 nano and define the width as 500 nano and click OK. Now save this and run this simulation. Now place this particular probe on the input and next place the probe on the clock. Now place the probe on the output. You can see the transient analysis of the flip-flop or the sensitive latch. You can see the input and the output simulation result for this particular latch. When the clock signal is high and the input flows to the output with a delay, and when the clock signal goes low, the value on the D input is captured and remains on Q output until the clock signal goes back to high again. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.